Okay. So let me show you a couple things. At the end of class last time, I was lining some stuff up. I want to show you a couple things I did here just so we can see it a little bit better. So if you remember, oh, why is nothing on? Shouldn't there be stuff on? I guess I could have manually turned the stuff on or off, but I just figured I'd reboot the system. There. Why are these things?
Right now they're set backwards so that when you turn the system on, it turns them off.
Really?
I don't know who messed that up, but yeah. But they were on a second ago, and when you turn the projector on,
Oh, I see. All right, so what I did here, and I think I mentioned last time that something you're going to have to do a little bit in practice is how to kind of manipulate our world here and move stuff around. And it's been a little bit since I've used it, but it'll come back pretty quick, I think. So what we've done here so far is we have one game object, our cube that we have here that we've been messing around with. I'm going to go ahead and actually just get rid of this other one. And then I have the floor. My floor is another, I started it off as a cube, but then what I did was I just kind of stretched it out. So here's my floor. So my floor is has a scale of 100 by 100 by 0.3. So it's, skinny. it's a skinny floor that's 100 by 100. All right. And so I double clicked on floor over here. And what that does is it centers it on whatever axis I currently have selected. Right now I'm looking at it on the X axis. If I look at it on the Z axis, I'm going to see something pretty similar because I have it 100 by, I think I have it 98, but basically 100 by 100 on the, if I go onto the Y axis, I'll be looking at it straight down. If I double click on this again, it zooms out. So it's centered on the screen. So I'm looking at my floor straight down from the sky. So you'll kind of get used to manipulating the view so you can see the stuff you want to see. And if you look right here, that little white dot, that's our cube that's sitting above it. Because what we're doing is we're trying to create a cube that's hovering above the floor and then the floor. And if I double click on the cube from this view, it'll zoom in on the cube. That if I click on the X, it'll show the cube from the side. If I want to zoom out, I'll see the cube. Actually, I'm looking at it to the reason I'm not seeing the floor here is the floor is really, really, really skinny. So if I did make the floor a little thicker. Oh, we're still not getting the light from it. I'd have to go at an angle, but that's okay. Okay, but anyway, so that's that guy. If I go and look straight down on it, now we see the floor. You see the shadow of the thing above the floor, so we know the thing's sitting above the floor there. And then if you start, Now I'm just free form dragging this around so I can kind of see where it is relative to the floor. Okay, now by default, I'll go into the floor here. I'm going to remove this material I have in here. We'll just talk about that for a minute. So by default, our floor is white, just like the box is. Okay, so what I did under assets here is I decided I wanted another color. And actually, I need to get this material completely removed because the white comes from the mesh renderer. Why can I not delete the floor? I want this one component to go away. And I would think don't know. I can't make it go away. I should be able to delete the material. I'm not going to worry about it right now. What I did in here is over here under assets, I right clicked. I said I wanted to create. And we have a whole bunch of things we can create. One of them is called a material. So material is kind of like a layer. You think of it like a coat of paint, but it doesn't only have to be paint. You can also make materials out of other images and things like that. But I created a new material. And I can go ahead and so this material gets added here. This is just an asset. So I'm going to call this guy blue. And then up here, I can select my color. So I'll just kind of select somewhere here in the blue. So there, now I have a blue material. And then what you can do is I can click on the floor and I can change the material I'm using, or I can actually just drag blue onto the screen here. And it will put that, just drag it onto the object you want it on. So now I have a blue floor. All right, so just give me a little bit of color so I have a difference between my objects that are sitting there. All right, so go back to the floor. And the floor right now, I only have a box collider on. So the floor, I don't want to be a rigid body. It can be a rigid body. So last time we were talking about the difference between colliders and rigid bodies. We were mostly talking about rigid bodies and just started talking about the idea of colliders because we want to see how our box and the floor can interact with each other. So we have the idea of colliders. These would be things that are collidable. All right, so colliders bump into other colliders. And the floor is just going to be a thing that's there. It's not an object we necessarily want to have mass or physics, although we could in real life. You know, this floor does have a physical mass. If I pulled up the tiles, they have a weight and things like that. And you know, the various physics characteristics of this floor would impact what would happen if I dropped this coffee mug onto the floor. So if I wanted it to have more of a natural reaction like that and have the game engine do all the physics math and stuff, I could. But right now I have this guy does not have a rigid body associated with it, which means he does not play the game of gravity. He doesn't have the option of playing the game of gravity. If I click on my cube here, we see this guy. He also came with a box collider. So by default, when we created one of these objects, they have a box collider. We can turn the collider off if we don't want it to have a collider. We'll mess with that a little bit here. We did make it a rigid body and we said, okay, gravity happens to you. So that means that right off the bat, gravity is going to be forcing this guy out of the sky. Right now, I went ahead and turned off my box script. We'll play with that a little bit more today, but I turned that off for right now. So when I hit play now, my cube is going to have gravity impacted, so it'll start dropping out of the sky. It will then bump into my floor. The two box colliders will interact, and the default material for this, the default behavior for colliders interacting with each other is to stop. Let the physics play the game, as opposed to if we change this to is trigger. We'll see this in a minute. They actually won't have a default way they interact. Instead, they'll go right through each other, but I would have been able to programmatically handle the fact that they hit each other. Because sometimes in a game, you don't necessarily want something to visually happen, but you still want to know programmatically if some event occurred, like two things bumped into each other. So if I hit play here, play. So our box falls out of the sky, lands on the floor, the colliders interact, and it stopped falling. Now, if I come in here, remember anything I change while the thing is still running won't have a permanent thing. So if I change my collider to trigger, see now the box went ahead and fell through the floor. Okay. It's not that the collider no longer worked. It's that instead of the collider having a default behavior, it instead sent some signal that I can choose to handle programmatically. And then I could tell the box to blow up. I can tell it to play some animation, whatever. I can do all sorts of different things as a result of those guys bumping into each other. All right, so now we're going to go ahead and we'll turn our box script back on. And I turned the is trigger off for our cube. All right, so my box script right now, it has the direction. We put in two public variables, remember from last time. So over here in Visual Studio, this is VS Code. So over here in Visual Studio, by making both of these variables public, it exposes them to my interface builder, to Unity. Last time we talked about the idea of this design pattern called MVC, Model View Controller. Model View Controller says it's a good idea to keep your interface separate from your logic, separate from your data, and then have some sort of clever ways to get them to interact with each other. So what we're looking at here is our logic. What we're looking at here is our interface. And we can make these pieces of the logic go into the interface by putting the word public in front of them. And then once we do that, by putting public there, we get, by our box script here, we get a go up and we get a speed variable. These two things have been exposed to our interface builder here so we can do things with it. So right now I have the speed set at 4, which is going to put some velocity in the upwards. Actually, I have velocity going in no direction right now. So it's, I'm wasting my time putting any force onto it. But if I wanted to change that and I wanted to put it on Y, oh, my box script is turned off. I'll make it a 1. Now we see it's floating up. If I change this back to a 1, is it coming back down? Let's make it a 0.1. I think that'll make it fall down. So you see the, I think the thing's getting a little bit bigger. Oh, it is falling. Okay. Yeah, here's my Y value. So it is dropping out of the sky. Now it's dropping faster till it finally hits. Okay, so that's just playing around with the velocity of a rigid body. So just like, so what we want to focus on right now is the two-way street here. I wanted a couple of variables from here to be available over my interface. I did that by making them public, and now they're available here. But I also want to make some stuff from here available in my code, right? Because what am I applying the velocity to? I'm applying it to the rigid body associated with this cube. All right, so this game object, this cube, he is the guy that has this script attached to him. All right, so the game object associated with this script, this dot game object, that guy is this cube. And that cube has a bunch of components. It has a transform, it has a box collider, yada, yada, yada. It has a rigid body. Rigid bodies are the things that make this guy like a physical object thingy. Okay, so in order to get access to this game object, and specifically his rigid body in code, I have to have some way of programmatically asking for that. And we're already doing that. So if I go back over to the code, one direction was, how do I make variables from in here available out there? I make them public. How do I make things from out there available in here? I use my connection, because this is this script. That's the game object associated with this script, which is our cube. I'm going to ask that cube from one of his components, specifically the one that's the rigid body. So I'm going to get a variable here of type rigid body that is going to be the rigid body component of that, that cube. The particular cube that this particular instance of the script is attached to. I can attach this script to 30 different objects if I want. And then this line of code would only be applicable to the one object that this particular instance of the script is attached to. And then I'm going to set the velocity of that rigid body to a direction, whatever go up is, times the speed that speed is. And notice I didn't, well, I did default speed here, but these guys are set externally in our interface builder. Go ahead. It makes it a float. And this is, it's a good question, because up to this point, if you remember back when we first introduced primitive types, we said, you know, we have byte, short, long, char, float, double. But what's kind of interesting is doubles are kind of like longs, where floats are kind of like ints in terms of they hold different size values. But the funny thing is in modern programmers typically will use an int whenever they're using integers, and they'll use doubles whenever they're using floating point numbers. Well, historically, a lot of the physics libraries and things like that, that these things are based on. So behind the scenes here, Unity probably uses OpenGL or some offset of it. So an old C or C++ library for handling the 3D stuff. Well, all those things are done in terms of floating point values. A double is a float, but a double has it holds a larger value than a float holds. So me putting an F here at the end of it says treat this guy as 2.0 as a float. Makes sense? So a float is 32 bits followed by a decimal point followed by 16 bits after the decimal point. I think that's typically what a float is, whereas a double is usually 64 bits before, 32 bits after the decimal point. Let you hold bigger values with more precision after the decimal point. All right. If I left the F off, I bet you it would still be fine. Since oh, it's not. It wants this, yeah. 2.0 by default is double precision. So it wants me to flag this. This is a double literal. The default for 2.0 is double literal. I want it to be treated as a float literal. I am kind of surprised that it wouldn't have said, oh, well, you're trying to shove it into a float. So if you do that, putting that guy into a float should just treat this guy as a float. Just like if I put it into an int, I would probably get a warning here saying that I would lose precision. Although maybe some hard coding, it would be an error, but an int is not capable of holding a decimal point value. So 2.0 or 2.7 is a 2 if I try to shove it into an int. Go ahead. Oh, so like instead of putting the F on the end of it, can I do this? Possibly. Yeah, I'm guessing that'll work. So it's probably fair to say I can't with 100% confidence say this, but I'm fairly confident that putting the F on the bottom effectively does what we're doing right here. I bet you the identical thing is happening behind the scenes. But the F makes it a little bit more convenient for us to describe a floating point value. Okay, so the thing we want to get here is from an MVC perspective, how do we expose things from our code to the interface builder? And then from an MVC perspective, how do we expose things from our interface builder into our code? This is how we grabbed something from our interface builder into code by talking about the game object that this script is attached to. All right, makes some sense? All right. So now what we want to do is we want to do some movement, okay? Remember that this update function, okay, this guy is something that happens all the time, okay? Every single frame, this update function gets called. So do I still have my game running? I don't, but as long as it's running, update's going to keep getting called over and over and over and over again, all right? So anything we do in there will occur. Right now, I'm not going to update the velocity yet. Okay, so what we're going to do is let's respond to some key commands. Okay, so let's go and look at look in the documentation. Say Unity key pressed. So we have a function called input, or an object called input get key down, and we can do it based on space. So actually this would be a good one. We'll steal this real quick. Now I'm going to move some of this stuff around a little bit. So I'm going to say inside of start, inside of start, we'll go ahead and grab the rigid body that's associated with this game object. That way we're not getting the rigid body every single frame. We'll get it once, and now we have the rigid body associated with the cube. And then inside update, we will only conditionally do something. So if the space bar has been pressed, right now we're printing space key was pressed. I'll actually go ahead and do that just so you see where that stuff shows up. We have like a console in the bottom of Unity. So I'll save this. We'll go back out here to Unity. And I do wish in Unity I had a way of either making some of this stuff bigger or making it, well, I don't know, I guess. Can you see this stuff okay? Like the boxes and stuff? It's acceptable enough. I was seeing if I can make it lighter, but maybe that won't actually save the problem. I'll look for it. Oh, editor theme, light. Is that better? Okay, so I should turn it back to the other one. just immediately. I want you to be miserable. Okay. Yeah, actually, I can see this better too. So this is all sorts of better. So now what we're going to do is when we hit play, our script currently says every single frame we're going to ask a question. And we're back to how do human beings solve problems? We remember stuff. Boom. We ask questions. Boom. And repetition is actually being represented here by our update automatically getting called every single frame. So every single frame, we're going to ask the question, was the space bar pressed? If yes, we're going to print out space key was pressed. I'll go ahead and hit play here. Now, before I do anything else, notice by default project is selected here. If you click on console, this is going to give you the thing where that print statement's going to come out. So I just press the space bar and see where it says there's this space key was pressed. Space key was pressed. All right, so this is happening over and over and over again. But right now it's not happening anymore because I haven't pressed it. So this is conditionally asking that question every single time. So now what I can do is if the space key is pressed, then I can apply velocity to this guy and kind of make him pop, jump up in the air a little bit, right? So I already have my direction here. So it's the up direction. I have a speed of 4. That's reasonably powerful. Let's see if that's going to be enough to notice. So instead of saying the space key was pressed, I'll say if you hit the space key, go ahead and set the velocity of our rigid body to the vector that is in the up direction times the speed. So it's kind of like you think about like slapping it. You know, we're slapping it in a certain direction with a speed, with a velocity, and it will send it in that direction at that velocity. Now, but keep in mind that this is pushing up against gravity. So instead of it going just flat out at that speed of 4, it's going to go up, but be slowed down by gravity at a constant force. So right off the bat, it's going to be like a 3.9, 3.8, 3.7, whatever, be ticking down. So it won't stay up forever, and eventually it'll just drop back down because I'm only going to hit space once. We'll go ahead and save this guy. We'll hit play. There's my space. Little Mario jump until he becomes the bigger Mario. We can jump higher, right? But we can cheat. We can just keep. Found a bug already. Good. Holding it down didn't work because I didn't press it. I think there actually is it's an event that the key was pressed. I think there is an event that you're talking about that will handle it being continually pressed. Yeah. Oh yeah, look at that. Okay, so tell me, why do you think it's doing that? Yes, kinematics aren't turned on. So kinematics says don't apply physics to the masses. But you're interested in why is it rolling like this, right? And that has to do with how a box collider works. So a box collider, we essentially have this cube surrounded by a box. Okay, now it is a little interesting as to why it got tipped a little bit at all, because we did have a direction going straight up. So I'm not sure I have a great answer for that. But as soon as the, so maybe it's something how we're applying the velocity, almost a race condition. As soon as it got a little bit off kilter, now all of a sudden our collision points are on the corners of the box, not on a flat surface of the box. So let's see if we can explain why I want to look at the cube first. The cube is completely flat. Is my floor's rotation completely flat? It is. So when gravity is a force directly down, maybe something with the angular drag. Let me just take it to a 0. At this point, I'm just guessing. Collision detection is discrete instead of continuous, which is okay. Continuous would be while it's still sitting on the surface, it would just keep dealing with the collision in case the like the floor moved or something like that. In this case, that's not happening, so that shouldn't make any difference. Anything under constraints of interest. All I changed here is the angular drag, and I wouldn't think that would make any difference because there are no angles. Oh, a little bit. Yeah. I don't know if I don't have an explanation. I don't know how it's getting off. Maybe it's something with when we're applying the velocity to it. Yeah, I would think the velocity would get applied at the entire rigid body surface. It's almost like there's wind. There's wind or something just blowing it up just a bit. Yeah, I don't know. I don't know the answer to it. It'd be interesting to know. I mean, if I click on, I mean, so we can see what the collider looks like here. So under box collider, if I click on edit collider, let me go ahead and zoom in on this guy. Okay, you see what that collider looks like, and the little green lines are the deal. So I mean, it looks like it's completely flat all the way around it. So it's not like it's landing on some edge. And my cube doesn't have any rotation. My floor has no rotation, so these guys should be hitting each other completely flat every single time. I'd be interested if you end up figuring out what's actually going on, but I don't have an explanation. Okay, so for input, get key down. We have names of our different keys. And let's see. So for the list of key identifiers, see conventional game inputs. All right. We can also deal with input using get access, which I think is the arrow keys by default. But let's look at get game input, because at this point, this is where I'll make some of the connections for us. And I've mentioned it before, and you're actually seeing it over here for input manager, because you have mobile device input. You also have XR input for augmented reality and virtual reality, kind of both of those guys at the same time. So when you think about any sort of 3D game or 3D application, 3D experience, the only difference, whether I'm doing this on a flat 2D screen like this, or if I'm doing this in virtual reality, is the camera. All right, because if I'm in VR, I have a headset on, and I have two hand controls, let's say, and when I turn my head, that headset's moving. That's kind of like, you know, my camera, right? My camera is actually moving on a swivel, and then also I have these two other tracked devices. So I have things, and these are controllers, right? In my game right now, this keyboard's my controller. Maybe the mouse could also be my controller, but you know, the difference is both VR and 2D here have, or a flat screen here, have controllers and have a camera. The nature of the camera might change. The nature of your controllers, the way you're interacting with the game might change, but you're still going to write the same kind of logic. You just might make a difference between, oh, I press the space bar as opposed to I click the trigger on my left, you know, VR controller or something like that. I'm asking a question of what just happened last frame. If you click something that I care about, do something. Make some sense? All right. And you've actually seen this probably for those of you who are gamers, when you can change the controller mappings. Sometimes you like hitting one button versus another one. What they do is they just have a bunch of variables that say, you know, this is the default for these things. And if you change it to a different thing, it just updates what the key name is, or the button name is. Okay. So we have our letter keys. This is just the letters of the alphabet. You have the number keys, arrow keys, up, down, left, right, up, down, left, right, Did any of you ever, is that just, I know that's kind of like a meme thing now, but any of you ever play Contra and put that code in? I remember the day we discovered that code. Yeah, we were at breakfast at this Red Wheel Inn place in like, I don't know, 1986 or something. We were so excited. Now we can just beat this game without any sort of, and that's cheating. Like, it's not fun anymore, is it? But it felt like as like an 8-year-old, we had tons of fun for a long time. But I mean, that, like, I'm thinking my today's mentality, I would like, oh, I'll beat it once, and that's kind of it. I feel like my brother and I beat that game hundreds of times using that cheat code, and we were every bit as excited. I mean, we were real idiots. We entertained so easily back in the 80s. Okay, so let's mess with our keys a little bit, and let's try to get our cube moving in some different directions. All right, so I can put in some code. So let's just say I'm going to hit, so what do I have? Up, down, left, and right. So we're going to go into our code here. And we're going to say, if we hit up, we're going to do one thing. Else, if we hit down, we're going to do another thing. Else, if we hit left, we're going to do another thing. Else, if we hit right, we're going to do another thing. Get rid of this print statement here. Actually, I'm going to leave the print statements in just for a minute. So make sure we're responding to the key presses correctly. It's down. I comment out that guy. This is left. That guy. This is right. Comment out that guy. Okay, so I'll go ahead and save that. It's compiling my scripts again. Go ahead and run it, and we're going to be interested. Make sure whenever you're looking for output, you have the console selected here. So I'm going to hit up, down, left, right. Hit the space bar. It's no longer, I don't ask the question about the space bar anymore. So that's correct. Okay, so now I'm responding to up, down, left, right keys. When I hit up, I might want to go forward. I can go ahead and I'll put the space bar back in it so my guy can still jump. So we can say else if space was pressed, we'll go ahead and make him jump. All right, so now he can jump again. And I'm still responding to my other keys. All right, so what should change? If I hit the up arrow and I want him to go forward, not up in the air, I want him to go forward, what do I need to change? So I need to change this, my vector, the vector by which I'm putting the force, right? So if I come back in here and I can say, well, right now I have go up. Let's just make this guy not public anymore. So let's create several vectors. I can actually do it this way. Go down, go left, go right. Say go jump. All right, so I have this vector 3 thing, and we saw it before, but let's go and look at the documentation in case we need it. How do we create a new vector? I'm going to say vector 3. Is it going to give us a? That was not all that great at searching the. So let's just say Unity vector 3. So. All right. Oh, so this is actually interesting. We're going to pretend like we don't see those for a second. Actually, let's pretend we do see them for a second because you're going to see how well this maps. When you see the word static, what does that mean to you? We dealt with it a whole lot with our Java, and it was one of those missed questions on the exam that I told you was going to be on the exam. When a method is static, what does that mean? Or a field is static? Who owns it? The class owns it. How do you call it? Using the name of the class, right? So, for example, if I want to say up, and I'm inside the class called vector 3, how do I change my spacebar here to no longer be go up? How do I call the up field, the static up field of the vector 3 class right here? Well, no, it's not this dot up. It's static. Who owns static? Who owns up? Vector 3 does. How do I call it? Vector 3 dot up. So there's my vector 3 dot up. Now, I could have also come into my code here and maybe inside of start, I could have set go up equal to a new vector 3, 0, 1, 0. And then I could have said go up here if I preferred that. So I can still hard code in vectors if I want them to be. All right, this guy still works. All right, so for your homework, I'll leave right here at the end since I haven't shown you how to put it online yet. Here's the current state of the code, and I'll put that in Slack. Make your cube move in all the directions, including up. So make it drivable. You can drive your cube around the screen. Make some sense? Okay, you can use whatever colors and stuff you want because for this one, I actually only care about your code here. I'll be able to tell whether it's working based on your code. All right, next time we'll somebody remind me at the beginning of class, I'll show you how to use GitHub for Unity. So you can start putting your GitHub stuff on Unity without your projects being 7 gigabytes in size. All right, questions, comments, concerns, bribes. All right, I will see everybody on Monday. I'll put the homework in the slides too, but then I'll put it up on Blackboard. Homework. Create a Unity project where a cube is drivable in all 4 directions, including jumping on a floor. Submit your code and the self-assessment. Floor moves too. I'm pretty sure, or you have gravity checked.
I looked at it.
Let's take a look.